Okay, good afternoon, everybody. My name is Mikael Palm, and as mentioned, I'm the pre-sales consultant in AVEVA for manufacturing execution systems, and I'm acting in EMEA region. A little bit about my background, a little bit quickly. I am coming from the automation. I started with automation maybe mid-80s, so I've been through all the layers: sensors, field buses, PLC, DCS, SCADAs, batch system, all the way up to level 3, to layer 3, where we have MES. And it was into the layer 3 I moved about 8 years ago. My industry expertise comes from the process industry, and it's mainly from food and beverage. And I was mainly doing food and beverage, and I have been commissioning dairies for 10 plus years. So that is a little bit from where I'm coming. I will continue the presentations from David now. He just started that on composable MES. I will call it probably composable model-driven MES. And I would like to start by positioning manufacturing execution system from beginning. And this is actually the slide where our professor, Henrik von Schell, in the beginning, he ended his presentation about Industry 4.0 with MES system. And that is from where I plan to continue. So let's go a little bit from the beginning. This overview shows where MES sits in the manufacturing stack and why it's matter. It's the real-time operational layer that connects the enterprise systems to what actually happens on the shop floor. MES is not only software, it aligns people, it aligns processes and technology. It guides operators with the right step, at the right time, enforces best practices, and it ensures a consistent execution across shifts and lines. MES is converting the activities from enterprise layer into actionable, traceable work on the automation side, and then returning back actual performance and genuality back to the enterprise systems for a visibility and a better planning. This connection improves the planning accuracy and the scheduling mainly. A core MES value is digitizing work, electronic work instructions, electronic batch records, and automated data capture. The outcome is less paperwork, fewer manual handoffs, and faster, more reliable production reporting. MES provides a procedural control. It helps reducing the human errors by orchestrating and tracking each step of the workflow. This is also where MES supports quality and regulatory compliance. And another key role is the real-time performance visibility. We are monitoring downtime, we are monitoring losses, quality issues, and also throughputs. Instead of discovering the problems after the fact, MES enables a faster corrective actions based on live data and contextual insights. Oh, that was final. That was it. And finally, MES tracks the full transformation of material into finished goods. What was used, where, when, and by which equipment, and under what conditions. So the conclusions of an MES system, where it is positioned, it is actually ERP plans, automation runs, and the MES is actually enforcing the manufacturing operations. So what is the composable MES, or as I said, the composable model-driven MES? Model-driven is configuring the production logic from, example, we have the processes, we have equipment, we have the master data, we have the workflows, we have the quality, etc. And this by using a low-code tools to adapt and reuse capabilities faster than custom coding. Composability is built from a modular, reusable use cases that can be mix and match to deliver value quickly and scale over time. The approach is drag, drop, and configure. Step-by-step logic for execution, approvals, checks, and exceptions are created, and user interfaces for operators and supervisors are configured. The model is composed by selecting and assembling the required use cases. It's not by writing a large amount of code. AVEVA provides you with a pre-configured MES use cases built from the industry best practices. These are not just generic examples. They are designed as reusable building blocks that can be deployed quickly and then adapted as needed. Every manufacturer has their own local variations. They have different products, they have different equipment, different QA checks, and approval steps. With the model-driven approach, customers can derive, create, and deploy their own libraries of MES use cases, as David said. So local needs are supported without breaking the overall standard. Once a use case is defined, you can reuse it across multiple sites with a consistent workflow and a consistent user interface. This enables a sustainable standardization, common KPIs, and common execution logic. So, how do AVEVA approach the MES deployment? It is think big, start small, and scale fast. This to deliver the value quickly without locking customers into long and high-risk deployments. First, we have a short time to value. The idea is to start with the ready-to-use MES content, pre-built use cases, common workflows, and functional modules. Because the solution is composable, use cases can be implemented quickly to prove value. The capabilities are then added incrementally rather than doing everything in one big program. Lower TCO. Composability and reusability reduces both deployment and ongoing maintenance. Extending more lines and sites, the reuse of the same building blocks are lowering the risk and effort. This also supports a better scalability and extensibility, so changes don't require any expensive rework. Model-driven adoption. Instead of hard coding every variation, a model-based approach is used that can be extended with a low-code, no-code configuration. That means adapting to site or product-specific requirements while still supporting a multi-site standardization. A standard where it makes sense and flexible where it matters. Going into this one. I will now build up AVEVA's composable and model-driven MES approach in 5 steps. Standard AVEVA MES installation, including workflow engine and database configuration, have been the same for decades. Exactly. To integrate the standard MES capabilities with the composable approach, the framework is installed as a backbone. Included in the installation are the 2 user interfaces, supervisor cockpit and operator cockpit, the only 2 basic graphical forms that is required. Second step is to install the modules from the library to fulfill requirements from the project scoping phase. Order management, job management, inventory, performance, quality, etc. They are all individual modules that are installed and connected to the framework without any horizontal connections. This gives the full modularity to upgrade without interrupting the execution. Another important value with this one is the approach is that it can be installed and coexist in existing installations. This means you don't need to reinstall when you're rebuilding something, and you don't need to start from scratch. The library is version handled and managed by AVEVA, and it's upgraded according to a roadmap. New required modules can be created by AVEVA or the partners that are assigned to the practice program. Third step is to install use cases from a comprehensive library of capabilities and informational user views. This library is also hosted by AVEVA and contains standard MES features that are integrated into the modules. For example, if I take the weigh and dispense use case, this is integrating a graphical user interface to the job management module in order to read the bill of material. It also integrates to the inventory module to validate the material is available, but also to validate the material location. And it integrates to the quality module, so to execute the quality checks. This library is open so engineers can easily modify the business logic and use experience in the embedded, low-code, no-code editor to exactly fit the requirements. The use cases can then be distributed to AVEVA's library. Oh, there we go. Next step is to compose the use cases for frontline operator and supervisor roles. This is the task for local administrator or process engineers to configure where the use cases are to be executed according to selection criteria in an easy format. We have user roles, equipment location, capabilities, the recipe, the material, the certificate, etc. For example, back to the weigh and dispense use cases. This can be configured by the process engineer to be executed in a dedicated location for a specific operator role with a valid certificate. Important again, the composing does not require AVEVA or a system integrator. This is done locally by your local peoples. And finally, we integrate with the control system and device using AVEVA's agnostic connectivity. Done in 5 steps. Easy. So now, for a few moments, I will leave the beautiful art of PowerPoint and show you a film clip of a composable and model-driven MES with different roles using the 2 interfaces, supervisor and operator cockpit, and we will see different use cases. Enjoy. I'm logging on as a production manager to my system. I come to my home page, and in my home page, I'm logging in to my supervisor screen that gives me the capabilities I'm configured for. In these cases, I can see my use cases, and the use case I'm interested, assigned to me, that is the order management. In the order management, then I can see all my orders, completed or not completed, and then they are contextualized to actions I can do. I can view some, I can change something, I can edit, delete, and I can change. I can also go into the bill of material and change the recipe. I can also see the status of the procedures. That is a use case in supervisor screen. Now I'm logging in as an administrator. Now, administrator, I get different role, different opportunities. I'm now going to configure this one. So in the order management, only the production manager in site A can do and act as a product manager. He will be able to do changes. In this case, his name is Mr. MD Admin. And Mr. MD Admin is the only one who can do changes or actions. All other ones who is not configured in here, they can see it. So to prove this one, I'm logging in as a production supervisor in area B. I get to the same homepage or configured home pages. I get some less options because I got different configuration, but I still go to the supervisor screen. In the supervisor screen, I have another set of use cases. But for example, when I'm looking at the order management, we can see the composition of this one only allow me to view. I'm not allowed to act on orders in area A. I'm moving into the next operator cockpit. So now I am the operator in filler number 1. I'm logging in. I can see the status of the machine. I got the performance dashboard to see how my work orders is going, and I got the task list, and I got a lot of use cases to see. In the task list, I can see the jobs I need to do, quality checks I need to take. I can see my performance in use cases, and I can also see the quality, what has been done, and what qualities needs to be done. I can also connect to the SCADA system to get the deep information, and I can also connect to the historian value to get my process data. Now I'm logging in as a process engineer. And as a process engineer, I will define a new built-in with new board machine, a blender number 2, and I will configure this one with 2 use cases. One use case is for blender number 2, it is, before I can start, when it's ready, I need a checklist. When I have started it after the checklist, then I'm going to run a specific use cases for production blending. Moving over to the operator at the blender 2, he got the same operator screen, as you can see, and when he's going to start that operation, you can see there is a checklist. He needs to check that checklist before he can start, and when he starts, he gets the use cases for the blendings. That's a mix use cases. The final operator cockpit task I'm going to show you is a weighing station. So the weighing operator, he logs in, he comes to the same operator cockpit where he sees all his weighing operations. And these are in a programmable sequence that is configurable by the process engineer. We're checking the stock, we are checking the instructions, we are also scanning the destination, we are scanning the material, and then we end up connecting to the scaling instruments to do the weighing itself and finalize that with the dispensing. I'm going to end my journey now on the full production by logging in as a quality manager. There is an indication in the filler that it is not really okay. So he's logging in into the supervisor cockpit. He browsed down to the filler, and in the filler, he can see he got other use cases, and he starts to investigate. He can see the performance, he can see the OEE, he can see the downtime management, indicating if there has been something, and so on. When he found out, yeah, there is some downtime and there is some events happening to this one, he can go into the quality checks, select the quality checks, and do the SPC graph for the SPC rules to see if there is a deviation. If there is a deviation, he got the information about the work order, he got the information about the batch ID. And with that batch ID, he moves to the next use cases, and that is the inventory. In the inventory, he scans the batch ID, and then he gets the full genealogy in a graphical way. In this case, we are showing it in a Sankey diagram, where we can trace forward and backward in all operations with all the batch IDs affecting into this one. And of course, if needed, he can drill down into the work orders to see the history of the work orders, everything that happens on that one. That was the film clip of today. A game changer with the composable MES is the time to value and the actual gain in efficiency. We are comparing a traditional deployment and rollout with the incremental method. In a traditional rollout, the full scope is specified and developed in front. After this, the first rollout, the pilot, this is deployed, and then is the time, this is when you get the time to value. And after this deployment, then, and when the pilot is finished and approved, then we start to roll it out to the sites, site by site. In the incremental approach, user requirement specification, they are mapped with the composable use case library. They are deployed to the pilot, but they're also rolled out to all the sites that is affected by this one. And as you can see, this is a much faster time to value, exactly like David explained before, 4 out of the 13 projects we are doing. Gap analysis takes place to find the industry and customer-specific business logic, and existing use cases, they are modified and new are created. And those modules that are created, they can be returned back to the common library of AVEVA to be used in the next project. The incremental developments are rolled out in the phase the site and project can manage. Finally, I will now summarize the practical outcome of the composable and model-driven MES approach, what it changes for the customer, but also for the delivery team. Customer engagement improves because we can start with out-of-the-box use cases. That makes the evaluation more tangible. Customers can see working processes early, they can validate the fit, and they can give a feedback based on real scenarios and not on a specification requirements. Delivery efficiency increases for both our teams and partners. Reusable pre-built use cases and model-driven configuration, it reduces custom build effort, it shortens testing cycles, and making rollouts more repeatable across projects. It's a higher customer value, absolutely, mainly through the shorter time to value. Instead of waiting for the full program scope, value is delivered in increments. Start with a few high-impact use cases, then expand to lines, areas, and sites. That incremental expansion also supports a continuous improvement and typically increases satisfaction because results are visible much earlier. And this creates a smart manufacturing foundation, especially when paired with a hybrid MES architecture. And now I'm highlighting Connect. Connect is bringing together the data services, visualization, analytics, and application, so different stakeholders can use the same trusted operational data. Thank you.